Myself Vipul Patel. In this session, we are going to discuss on constant VF control using PWM inverter, also known as PWM based VSI drive. PWM stands for pulse width modulation. The PWM inverter with SPWM, here S means sinusoidal sine. SPWM technique is being used to implement the constant VF control here. The three-phase PWM bridge inverter is shown in figure. In this figure, you can see this is a DC supply and this RYB. At this point, we can get a three-phase AC supply. These are the transistors and diode. The base driving waveform driving the transistor Q1, Q2 and Q1, Q3 and Q5 are PWM signal which are shifted 120 degree from each other, where the base driving signal applied to Q4, Q6 and Q2 are 180 degree out of phase with respect to Q1, Q3 and Q5 to avoid cross conduction. In this diagram, you can see the PWM control of induction motor. Here you can see this is a PWM inverter. These are the PWM controller, and this PWM inverter output is given to the induction motor. The output voltage of PWM inverter is varied by varying the modulation index M, which is defined as the ratio of peak amplitude of the rectified sine wave and the triangular wave. The output frequency is changed either by changing the frequency of modulating signal, but this will change the number of pulses P per half cycle and hence the harmonic profile, or by changing both FC carrier frequency and FM modulating frequency, keeping the P constant. The DC input voltage to PWM inverter should be constant and not variable as in case of square wave. Therefore, the controlled rectifier is no more required and uncontrolled rectifier is used instead. Due to this, the input power factor will not change much with speed. The control voltage from RFG, that is ramp function generator, will control both the output voltage and the output frequency of the inverter. The RFG provides the desired soft start and soft stop for induction motor. Now, the advantage of PWM control is due to PWM output with a large number of pulses P per half cycle, the output is very close to sine wave. The low order harmonic are completely eliminated, whereas the higher order harmonics will be filtered out by the motor inductance. This will avoid the torque pulsation and motor heating due to losses in motor. Filters need not be used after the inverter. As the variable DC voltage is no more required, the input power factor is much better as compared to the scheme with a square wave inverter. These are the advantages. Now, disadvantages. With increase in number of pulses per cycle, the performance of the system improves, but the transistors will have to be switched at much higher frequency, due to which the switching losses will go up. Now, the another topic is closed loop control using PWM inverter. In this diagram, you can see the closed loop control scheme. In that, you can see this is the speed controller with RFG, flux control, current controller, tachometer, and 3-phase inverter, and this is given to the motor. Now the operation is the actual speed sensed by the echo generator is compared with the reference speed signal. The difference between the two is speed error signal. The speed error signal is applied at the input of the speed controller. The error is in speed is processed by a speed controller, which is proportional plus integral P plus I controller, and then the sleep speed regulator. The output of speed controller and sleep speed regulator output act as current reference, and it will decide the maximum value of armature current. So, by proper adjustment, the maximum armature current can be kept under control. The frequency of the stator voltage is decided by adding the output of sleep speed regulator to the actual speed. The frequency deciding signal the frequency deciding signal is then passed through a flux control block, the transfer characteristic of which is such that it will ensure a constant air gap flux by keeping Vf ratio constant. The flux controller output is compared with the actual armature current produced by a current transformer, and the error in current is applied to the current controller. The controller is P plus I controller, the output of which is used to adjust the value of modulation index M, which in turn will adjust the output voltage of PWM inverter. Because of the use of PWM inverter, an uncontrolled rectifier is used along with the capacitor filter. The speed and current controller should be optimized. Means their proportional gain P and integral time constant be adjusted to suit the motor parameters in order to have a stable operation over the entire speed range. The P plus I controller are used because they combine the advantage both proportional and integral type of controller. The P plus I controller therefore have the advantage of fast response and static error in speed. The RFG ramp function generator is used for providing the gradual acceleration and deceleration, that is soft start and soft stop for large motor. Thank you for watching this video.